So what we're looking at here is the data from one experiment. We've got A reacting with B to form C. So we're going to have B disappearing and C appearing. So, that's my boo. And it's going to be occurring over time. So what we have in our chart, we could actually sort of have a bit of a visual for, where the chart is over time. So this would be when they're just before the experiment started, 10, 20, 30, 40. And across the top here would be our concentration, which would be in moles per liter. And so at the beginning of the experiment, B, we started with actually quite a bit. So we started with 1.25. So let's make that a 50, a 1, and then a 150. So 1.25 would be up here. And then 0.8, and then 0.6, 0.5, something like this. So you can see that the amount of B, or the concentration in B, sort of declined over time, but then it looks like it's sort of petering out over the course of that reaction. And then C, when we start with C, we actually start with nothing. There's no C, that's just A and B together. And then we get it reacting. And so we very quickly kind of see this rise. And then a bit of a petering off as well. Whoops. So that bottom line that's going up and over is the product line, and then this would be our reactant line. So reactants sort of disappearing, products appearing, and then what we want to do is talk about the speed. Whoa. So we want to talk about the speed of that reaction. And in order to do that, we want to talk about the change in concentration over a change in time. So rate is going to be a change in that concentration over a change in time. So let's look at different intervals of time. And so for the first one, we'll talk about the consumption of B. So how is B being used up in the first 20-second interval? So if we go 0 to 10 and then 10 to 20, this is our 20-second interval. And if we want to kind of set this up, we want to compare the final time to the initial time. So the final time here is 20 seconds. And we're going to compare that to how much the concentration at 0 seconds. So in terms of concentration, we ended up with 0.6. And we began, so the units here would be moles per liter. And we began with 1.25 moles per liter. So this is really interesting. If you use your calculator, you're going to do a subtraction and you're actually going to get a negative number. So don't swap them around. Do them the way that they are from left to right. You do get a negative number. But when we talk about rate, we always talk about rate as a positive. So we don't speak to, I guess, negative rate. And I like to think about it as like putting a car in reverse. You know, if you're driving backwards, so you're getting a negative distance, is that, you know, you're not going like negative 30 kilometers an hour. So when we show our final answer, we're not going to include that negative. So let's do that division, and we get 0.0325 moles per liter second. And that describes our speed of the reaction over the first 20 seconds. So let's look at it over the last 20 seconds, from 20 to 30, 30 to 40. So that's a full 20-second interval. So we'll set it up again where we're going to put our time final first. So 40 seconds minus 20 seconds. And it's always final minus initial. So we'll look for our final concentration, 0.45 minus 0.6. And again, we get that negative number on top, but that's okay. When we do our division, we're just going to leave it as a positive value. And so if you look at these two values, 0.0325 and 0.0075, we would say that the top one is faster. There are more moles per liter being created every second than in the last 20-second period. And if I just remove this and go back to this, so we're talking about this interval here. So the first 20 seconds is like this. Wow, there's been a lot of change. And then in the second 20 seconds, there hasn't been a whole lot of changes, sort of petered off. And so that's where we see that change in rate. So this is quite a little bit slow, and then this one's a little bit faster, representing a little bit of a faster period of time. And I just wanted to show you how the average rate of reaction works with the product. So we're going to do between 10 and 30 seconds. 30 is our time final. 10 is our time initial. So 0.9 and 0.58. When you do this subtraction, the value is positive because this is a production or a creation of that product. And again, we're going to show it as a positive value for the rate.